lesson time. Yes, here we go again. And you made it back. Thanks for coming back for lesson 3. You're good people. And let me tell you, by the Eureka math standards, the lessons we do here should take actually, guess how long? About 60 minutes, sometimes even a little bit more. So if we take about 20, 30 minutes, we're doing fine. But also keep in mind, that might mean that you might need to go back and do things a couple of times if it didn't stick the first time. I have to do that all the times. Sometimes I've watched videos like 3-4 times. It's different watching videos. So cut yourself some slack, kid. All right, just go back and do it again. All right, speaking of going back, Jack, do it again. Today we're going to use exponents. Wow, this is a day you will always remember. The day you learned how to use exponents. When you woke up this morning, you weren't thinking, oh, I think I'll start using exponents. Perhaps you know what I'm talking about. Perhaps you have a little, yeah. But maybe you're like, what is that crazy man talking about? Yes, exponents. This is a fun one. You are going to be like Little Miss Fancy Pants after this one. This is a big old 5th grade thing. To name place value units or explain patterns in the placement of decimal point. We'll get to that. Let's do a little warm-up first to see you have a sprint. So if you have the paper, go pause the video, do side A, do side B, have a nice time. Okay. Now let's state the unit as a decimal. 9/10. I recommend you have out paper and actually write down these ones. Because when we write 9/10 as a decimal, how are we going to read it? 9/10. It's going to be like I'm going to be saying the same thing, but you want to see how it's written. And it's written as 0.9. See how these work? Okay. How about 10/10? Oh man, we jumped right in with the tricky one. Yeah, think of it as a fraction. 10 over 10, that's equal to 1, isn't it? Yeah, so 10/10 looks like this. We could read this as 1. If I saw this number, you could safely say 1. You could also say 10/10. You could say 1.0 is how you write it. 11/10. Well, after doing that last one, you know how to do this, right? 11/10, 1 and 1/10. Okay. 12/10 would be 1 and 2/10. 18/10, 1 and 8/10. 28/10. Very similar, right? 2 and 8/10. 58/10. Again, similar. 5 and 8. Where are we? Tenths. Very good. Okay, 9/100ths is straightforward. You're going to put a 9 in the hundredth place, so you need the 0 in the ones place. Otherwise, the number just looks kind of wacky, and you're like, why is this spot on my paper? So that's why we put the 0 in the ones place here, by the way. So for balance in the force. So we don't have to say 0 and, though. We could just jump right to it and say, what do we have? We have 9 in what place? Hundredths. Okay. So 10/100ths. Here's a little way I like to think about this. Okay? I'm just going to show you this one. I want to write the number, when I have it with a decimal here, I want to write the number 10 such that it ends in the hundredth place. And I'm going to jump back and show you, we could have done that here as well. I'm going to write 58 such that it ends in the tenths place. So even more so with this, I'm going to write 10 such that it ends in the hundredth place. That's a way of thinking about this. So 20/100ths, how would we write that? 20/100ths, okay. 60/100ths, how would we write that? Again, 60 such that it ends in the hundredth place. Good. Now similar, but 65/100ths. Well, we're going to write 65, so it ends in the hundredth place. There we go. 87/100ths, same idea. Write it down. We would write 0.87. 87, where are we? Hundredths. Great. Don't freak out on me. You're going to write 118. So write 118. And then say, okay, that 8 has to end in the hundredth place because it's 118/100ths. So the 8 needs to be in the hundredth place. So my decimal point goes here because I'm tenths and ones. Zingo zango. 306/100ths. Same idea. And write 306. And then place the decimal point such that the 6 is in the hundredth place. 3 and 6/100ths is the same thing as 306/100ths. Another way of thinking of this one as well, hundredths are pennies, right? Yeah, so if you have 3 over here, if you have 306 pennies, you have $3.06, don't you? Because each 100 pennies is $1. Yeah. Now we're going to move on to the next big thing. We're going to do times and dividing by 10. I'm not going to explain this quite as much because this is lesson 2, okay? So we're just going to kind of go through. Would you like to, if you're able to, write down your answers for these? Okay? So we have 2 thousandths times 10. It's going to move up one place, so now we have 2 hundredths. Very good. 4 thousandths, again times 10. Same idea, right? 4 hundredths. Okay. Now, taking that same number, 4 thousandths, and we're going to multiply it by 100. So now it's going to advance 2 decimal places to the 10th place. So 4 thousandths times 100 is 4 tenths. Got it? All right. Same number, 4 thousandths, now times 1,000. 1, 2, 3 places it'll advance times 10 times 10 times 10. And I mentioned this before, but I'll mention in this video as well that the decimal point is not a place. I just have to make room for it here so we're cognizant of it. So 1, 2, 3. Yeah, it's going to be good old neighborly 4. Yeah, our friend 4. All right, so now let's take that same 4 thousandths, but let's have 1 and 4 thousandths times 1,000. So both of those digits, both of those place value digits are going to hop up 3 places times 10, so 10s times 10, times 10, times 10, times 10. It's a tongue twister. So that leaves us where? 1,004. Notice we don't say and, we reserve that for mixed numbers in the decimal point. Let's read this number first. Here, we can read up here on the place value chart. 1 and 24 thousandths times 100. Everything's going to hop up 2 places. Can you picture that? 102 and 4 tenths. It's times 10 times 10. Great. Okay, I did this one just for fun. I can't resist. Cut me some slack, kid. All right. So let's read this number. Notice where the decimal point is before we start, and we have a comma here where we're going to say thousand. Okay, so 20,401 and 24 thousandths, and this is times 100. So all those digits are going to slide up times 10 times 10, 2 places on the place value chart, and so this is what we end up with. Now this comma, we're now going to say millions. This one we're still saying thousandths, and this we're going to say and for the decimal point. So let's read this number. It's a little tricky. When you look at the thousands, just read that as a number. We'd say 40. Just read that as a number. Okay, let's do it. 2,040,102 and 4 tenths. And if you find that simple to do, you're well practiced in it, bully for you. And if you find that tricky, the reason I'm doing this is because, in my experience, a lot of students find this tricky to read difficult numbers like this. So don't worry. Somebody who finds it easier, they just practice more than you. You'll catch up with some practice. Now we're going to go the other way, folks. Folks? That's a word now. All right, we're going to do 4 divided by 10. Yeah, so we're going down the decimal. Yeah, okay, so now we have 4 tenths. Okay. 4 and 1 tenth. Move them both down a place, divided by 10. Okay, let's look at the number here. 41, what place are we in? Hundredths, 41 hundredths. Okay. Same number, 4 and 1 tenth, but now we're dividing by 100, so we're both going to shuffle on down 2 spaces there. As such, let's read the number over here. We don't have to say 0 and, in fact, don't. Kind of awkward. All right, we're going to read this as a number. 41 thousandths is where we are. Read this number, 1,023 divided by 100. So everything is going to get smaller. 2 places, divide by 10, divide by 10, divided by 100. Okay, so everything moves down those 2 places. We end up with 10 and 23 hundredths. Very good. Whoo! Jack and Kevin been busy. They're creating a mosaic for art class by using fragments of broken tiles. They want the mosaic to have 100 sections. If each section requires 31 5/10 tiles, how many tiles will they need to complete the mosaic? Explain your reasoning with the place value chart. And before you do this, always stop and kind of picture it. Picture like there's this wall. Maybe they're drawing the floor, it doesn't say. I'm telling them to put it on. Kevin, put it on the wall. All right, so we got on the wall 100 sections. It's probably just 10 by 10, right? And each one, about yay big, doesn't say, needs 31.5, I said it that way, see, tiles. Okay, so 31 5/10, 31, let's call it round off just to get our heads around this. 32, 32, 32, 32, 32, 32, 32, 100 times. I'm going to do 32. So this number is getting bigger, okay? And the reason we do is we want to, before we go and say, oh, I'm going to add, subtract, multiply, divide, we want to kind of think it out. Why are we doing this operation? Because we have a whole bunch of 31 5/10 tiles. All right, so let's write out 31 5/10 on the place value chart. And this number is getting bigger because we have lots of tiles. We're multiplying by 100, so everything just shuffles 2 places up, doesn't it? And what do we end up with? 3,100. Wait, oh. Yeah, what? Oh, yeah. See, so we have to place, oops, click too many times. We have to place a 0 in the ones place. You see I do at the bottom there. 3,150 tiles, okay? Better get busy, Jack and Kevin. All right, here we go. We're going to get into the exponents now, finally. It's a great name for a like a high school team. So if your school has perhaps some offensive name and you're looking for a new one, call yourselves the Exponents. That's awesome. It has Expo in it. All right. Yeah, mighty pretty. All right, thank you. Okay, here we go. This is what exponents are. I'm about to explain exponents to you. This is going to do, remember, for the rest of your life. 10. We're familiar with 10. We know what 10 is? Okay, good. Got the fingers, right? All right. Is equal to 10 times 1. Okay? Are we still in agreement? All right, I don't want to go too fast here. All right. How do we write that as an exponent? 10 to the first power. I know, I just blew your mind. But wait, I'm going to wait to explain what that means. But you see it is a superscript raised up 1. When you write these on with a pencil, take your time and make sure it doesn't look like 101. That it's superscript, like the C in McGrath. You raise it up, it's superscript. And if you're using a computer, you might have to do as I did here and highlight it and go up to Format, Font, Superscript. Okay? So now, I'll explain what that exponent means in a minute. Okay? 100, familiar with that, okay? That's what in multiplication? 10 times 10. Correct, right? Is 100, okay? In exponents, we would write that as 10 to the second power, also known as, it has a pet name, it has a nickname, 10 squared. And again, I'm not going to explain it just yet. Just stick with me, Kevin and Jack. Here we go. What do you think's next? Yes, 1,000. Okay. What's that in multiplication? We've been doing lots of this. 10 times 10 times 10. Great. Okay. I bet you can guess. I don't know what to tell you. How do we write that as an exponent? Yes, very good, Jack and Kevin. It is 10 to the third power. Now let's see if you can guess this one. 10 to the second power we call 10 squared. What do you think we can call 10 to the third power? 10 cubed. Here's why this makes sense. Watch this. Here's a line. How many dimensions does it have? It has 1 dimension, length. That's it. Okay? At least our, platonic line in our mind. Okay, it has length, that's it. So that's why its length, let's say, is 10. That's why it's written as 10 to the first power, because it has 1 dimension. That's why 10 to the first power is 10, because it has 1 dimension. Stick with me, Jack. All right, now here we have a rectangle. Let's say I should have drawn a square. Oh my goodness. McGrath, you're fired. All right, okay. This should be a square. Oh my God, I blew it. All right, pretended I cut it in half. It's a square. Okay, now it is. So 10 squared, 10 times 10 is 100. It has 2 dimensions. That's why it's a 2, length and width. You see how that works? And then this one's properly. You're hired back again, McGrath. Thank you. Let's say each dimension of this cube is 10, length, width, and height. 3 dimensions. It's a cube, isn't it? That's why 10 to the second power is called 10 squared, and 10 to the third power is called 10 cubed. And that's why 10 to the first power is simply 10. 10 squared means 10 times itself 2 times. 10 to the third power, 10 cubed, means 10 times itself 3 times. And after that belabored explanation, you'll see the rest of the chart is pretty clear cut. Here is our good friend 10,000. 10 times 10 times 10 times 10, correct? How many 10 times there? 4. So 10 to the 4th power. And at least as I'm aware of, he doesn't have a cute nickname, because what is the 4th dimension? Nothing. Okay. Now, there's debate on that. Okay, fine. All right. Now, next number is 100,000, of course. 10 times 10 times 10 times 10 times 10. 10 to the 5th power. And you can say for these 10 to the 4th, 10 to the 5th, or you can say 10 to the 4th power. Depends who you're hanging out with, right? And then what comes next? Go up the place value chart. 1 million! And so now we're going to have 6 of them, and I'm out of figures. 10 times 10 times 10 times 10 times 10 times 10. 10 to the 6th power. Whew. Those little bad boys right there, guess what? Those are exponents. And they, see, I can use and explain exponents as powers of 10. By powers, we're saying how many times are you giving it power, how many times are you multiplying times 10. Here, we're doing times 10 once. Here, we're doing times 10 twice. 3, 4, 5, 6 times. That's what exponents are. They're basically, you can think of them as a shorthand way, because who wants to write out 1 million even? Or certainly not that mess. It's like, ugh, you can make your eyes buggy. When you can just write 10 to the 6th power. Pretty cool, huh? And here's a little cute thing. It's a special number called a googol. Now, before there was Google, I knew this word, and like when I was in like 3rd grade or whatever, like we would press people like, yeah, you'll have to do that a Google times. Witty math joke. But it's a number, and you see the spelling is different with the O-L there, okay? And of course, when Google was invented, I think this influenced their naming of the company, and they said, well, let's kind of make it like ogle, like to look at something, and Google, because you're going to get a lot to look at. That's my guess. All right, but here is this number. This is an actual number. A googol is 1 followed by 100 zeros, and it looks like that. That is 1 googol. Now, let's say you had reason to write that down. You wouldn't want to, right? It's quite laborious. So, and I want to be clear here, this googol doesn't mean anything. It's not a mathematically significant number. It's not like, oh, a googol is what you, like, you don't use this number for anything in particular. It's just a cool number to hang out with, you know. Makes you look prettier than you are sometimes. But how would we write it in a way without 100 zeros? We can use exponents as powers of 10. Each 0 there represents a place value, and each place value is a power of 10. In other words, times 10. So how would we write 1 googol using exponents? How? Yes, 10 to the 100th power is how you'd write a googol in exponential form. Whew. We've got 2 more things to do here. All right, 10 times 100. So if somebody throws this at you, and this will prepare you, by the way, for doing things like 30 times 700 and getting those things correct, all right? So we're starting off nice and easy. 10 times 100, well, we can think, okay, 10 hundreds is what? You have 10 $100 bills, you have $1,000. Can I borrow some money? All right, so 10 hundredths is 1,000. Okay, do you see the 3 factors of 10 here? Ah, yes, because 100 is 10 times 10. So there's 3 factors of 10 there. You see 3 factors of 10 and 1,000. And this is where we can get a little shortcutty. Count the zeros. 1, 2, 3. 3 place values is 3 powers of 10. 10 to the 3rd power, also known as 10 cubed. Hot dog and hallelujah. Now hold on to that, okay? Let's go back and look at that. Okay, because it's going to be helpful here. Watch this. Oh, 3 times 10 squared. We could say it to the 2nd power, but generally people just say squared. 3 times 10 squared. Well, let's just kind of like reason it out first. Okay, 3 times, well, 10 squared is 10 times 10, which is 100. Okay, so 3 times 100, 300. Okay, easy enough. But now, when I first said 3 times 10 squared, perhaps you couldn't just get right to 300 there. So we can start now using place value magic to make this easier. Watch the magic! Mathemagic. All right, so we know multiplying by 100, multiplying by 10 times 10, or 10 squared, the same as moving it up the place value chart. So another way of thinking this is when you're moving up the place value chart is as moving the decimal point. Okay? It's the same thing. Instead of moving discs or digits up a place or down a place value chart, we can leave the number stationary and move the decimal point. Here's what it looks like. Watch this. 3, we could write that as 3.0, right? We could even write it as 3.00. And here's why I'm doing that. So when I do times 10 squared, that 2 means 2 powers of 10, 2 places on the place value chart. 1, 2. See, so now I can look at 3 times 10 squared and say, 300. Watch, you'll see how you can do this. 6 times 10 squared, 600. 1 times 10 squared, what's sort of weird, but just take that 1 and go, 100, right? Because you're saying 1 times 100, aren't you? So it makes sense. Always do that logic check. 7 times 10 squared. 700. Look at that. You're doing it. Okay. What's different? One little thing. 10 to the 3rd power. 10 cubed. I bet you can do this, can't you? 7. 3 powers of 10. 3 place values. Yes, 7,000. See where that comes from? So we're going to pretend right there, that comma, we're going to pretend that was the decimal point, right? So we're doing times 10 to the 3rd. That means 3 powers of 10. 1, 2, 3. Booyah. All right, look at this one. We're going back to squared, but yeah, I'm giving you 7 and 2/10 to multiply here. But still, this is why I told you the move the decimal point is another way of thinking of moving on the place value chart. So 1, 2. You have to kind of imagine the 0 you'd have to place there, right? So 720. And that makes sense, right? Because 7 times 10 squared was 700. So 7.2, we'll say, times 10 squared is 720, okay? Practice makes better. Maybe not perfect, but better. 1, 2 places. Yes, 340. 1, 2 places. 910. Impressive. Yeah, that's right. Cubed now. 1, you have to picture this a bit in your mind. 2, 3 places. 9100. What number is that? 9,100. Okay? And again, the other way of thinking is you're taking that 9.1, the way you've been doing, and moving 1, 2, 3 places up the place value chart, and you would also end up with 9,100. Okay? Similar, right? 1, 2, 3. And the way I recommend doing these, and sometimes I have to do myself with bigger numbers especially, is I just write down the digits. So I'm going to write 90100, and then later on figure out where the commas go. Okay? 901, and I'm moving it 1, 2, 3 places, right? So I need 2 zeros tacked on there. And then I could say, okay, the comma goes here. It's a lot easier to do it that way than to try to figure it out while you're doing multiplication. 90,100. Woo! Woo! Times 10 cubed. 1, 2, 3. So I'll need another 0 there. And again, don't worry about the comma yet. Just write 540, 060, and then say, where does the comma go? Ones, tens, hundreds goes there, okay? 540,060 is how we read that number. Yes. Ooh. Oh yeah. Netflix. Okay, 700 divided by now 10 squared. Okay, exactly. We're going to still think of it in terms of moving the decimal point, but the number in this case is getting smaller, right? 1, 2. And we could think of the 7 in the hundreds place going 1, 2. From the hundreds down to tens to ones. Or we can even think of this as 700 divided by 100. And sure enough, it's 7. Okay? Having done that, let's look at it again. 700 divided by 10 squared equals 7. Now, I bet when you woke up this morning, you didn't say, I bet by the end of this day, I will be dividing by exponents. You're doing it. All right. 400 divided by 10 squared. Dun, dun. 4. Okay? 1, 2. It's 4. All right. 430 divided by 10 squared. Yes, same concept. 1, 2 places, decimal point goes here. 4.3. 4 and 3 tenths. Oh, it's cubed, so we're moving 3 places. 1, 2, 3. So it's going to be 0.43. And we know we need to put that 0 at the front end, right? So it doesn't fall off the cliff. So how would we read this? 43, where are we? Hundredths, okay? 9,807 divided by 10 cubed. Oh, 1, 2, 3. 9.807. And notice I am saying it that way on purpose, because just think about how to write it first before you think about how to read it. 9 and 807 thousandths. Very good. Whew. I know, yeah, you might be getting tired. If you need, pause the video, go take a little walk. Last thing here, this is last thing, and it's not as complicated, okay? Patterns. 2 hundredths, 2 tenths, blankety blank, 20. So what are we doing here each time? We're doing times 10 is, times 10 is, times 10 is. And we can discern the pattern just from here. And if you wanted to talk about it in terms of moving the 2 up the place value chart, you could, or by moving the decimal over. Okay, so what would go here? 2, good old friend 2. 32,000, 3,200, blankety blank, 32. 320. You're just taking that 32 and moving it down the place value chart, right? Because what are we doing here? We're doing divided by 10, divided by 10, divided by 10. That's the pattern. You might have test questions that say, you know, what is the pattern? It might give you all 4 numbers. But they might give you the thing and say, complete it and explain what the pattern is or what the rule is. Or you might see this as an input-output machine. What we're doing is, the rule is dividing by 10. All right, here we have the blankety blank first, then 5 and 7 tenths, 57, 570. And I know we're multiplying why? Because the numbers are getting bigger here. When you're multiplying whole numbers by 10, they get bigger. Okay, so 5 and 7 tenths, 57, 570. What goes in the blankety blank? Okay, how would you write it first? 0.57, right? And we need to place that 0 at the front end. So 0.57. How would we read this? 57 hundredths. And lastly, what's the rule there? It's getting bigger, so it's times 10. Very good. 99, we'll place thousandths. 99 hundredths. Watch, I could even read this as 99 tenths, couldn't I? As we did in the warm-up. And then, so this would be 99 ones. See, another way of thinking about this is what place are we in instead of reading it as a number. 99 thousandths, 99 hundredths, 99 tenths, 99 ones. And so what is our rule? The number is getting bigger by one place value each time, so it is a times 10 rule. Told you that was not quite as complicated as all that exponent stuff, but look at what you're doing for the problem set here. You're going to start off the same way we did, with just kind of working with these numbers, putting them in exponential form. Only tricky ones here, I'd say, are D and F. My recommendation for you, for example, look at D. 100 is 10 times 10 times 100 is times 10 times 10. So again, it's 10 times 10 times 10 times 10. Okay. All right, now write the following in standard form. In other words, just like solve, give an answer. And so watch the exponents, watch the multiply and divide. You may want to write the number off on the side and use the moving the decimal point strategy. If you have attached to one of these lessons a place value chart, or you want to draw a quick one, write them in there and as a way of checking yourself if you get a little stumped. And then in 3 and 4 here, you're going to do a little bit of thinking. These are the most important questions here. So think about your answers in problem 2 here. What's the pattern when you multiply or divide by a whole number of power of 10? One way to answer this is to reference the place value chart. So the pattern is, for example, when you're just, say, multiplying by 10, is that you're moving one place up the decimal of the place value chart, rather. Okay? If you're multiplying by 10 squared, you're moving 2 places. So in other words, you're multiplying by 10 to the second power, you're moving 2 places up the place value chart. If you're dividing by 10 squared, you're moving 2 places down the place value chart. So use the place value chart, and then note that first question is just for A through D. I can't read that. And then they're asking you basically the same question, but from about E through H, but also where do you place the decimal? So then you're going to talk less about the place value chart, but just thinking, well, times 10 is like moving the decimal point one place to the right. Divided by 10 is like moving the decimal point one place to the left. So times 10 squared is like moving the decimal point. You got it. Okay. So then we have just like we did Zuba. Go ahead and do the patterns. These are a little tougher though, because you see in some cases you have to fill in 3 of them instead of just 1. How did you find them? Similar questions here, so I won't go into as much detail. And then I love these questions where they're like, somebody got something wrong. Tell me what's wrong. So Shawnee, he missed the lesson on the exponents. Oh, so did Marlon. Okay. So he wrote 10 to the 5th equals 50. Now let me tell you why this question is here. It's a very important question. This is the number one error that students make when learning exponents, is they see 10 squared and do 10 times 2 is 20. That's not what it means. 10 squared means 10 times 10. Multiplying by 10 with 2 tens, a factor of 2 tens, okay? So 10 to the 5th means 10 times 10 times 10 times 10 times 10. It does not mean 10 times 5. That's the essence of the mistake there. I really probably gave you too much of an explanation. Sorry. All right, here's your exit ticket. There's more of that number crunching. Homework is the same as the problem set, but different numbers. And look at what you've done. You have survived a very interesting lesson. One you will remember for the rest of your life, exponents, powers of 10. So I will see you again next time. It is once again a lesson time.